Sorry, I think you maybe yours. Is it your mobile? Yeah. All right. So he has it, right? So. Mm-hmm. Yeah. All right. No, I think I'm good. It's all right. Yeah, no worries. So we will wait another 5 minutes. right, I think we can start. Good morning, everyone. Thanks for showing up. Otherwise, I would be all by myself here. So it's great, great that you're here. I'd like to talk about the open system firmware project that we have here at the OCP, and actually the initiative that we drove over the last 1.5 years on Intel Xeon-SP platforms. Actually, the majority of the work, or all the work, was done by Reddy and Neil. Reddy is senior principal engineers Intel, and Neil is firmware architect at ByteDance. However, both were unable to show up, so I took over. And I think I have all the details, or I hope I have all the details, but it could be that I'm missing some spots here and there. All right, let's get started. So what do I want to talk about, or what do we talk about today? First of all, the open system firmware project itself under the OCP, and also the term cloud firmware. Cloud firmware is a new term that was created basically by the open system firmware project. And then actually the execution, like how it was implemented on the Byte side. Things because ByteDance actually did implemented it in their own infrastructure. And I will leave you with a call to action to get you involved, more or less. Okay, let's see. All right, so what's cloud firmware? Cloud firmware, so basically hyperscalers got to the conclusion that they want more ownership on their platforms. And because more ownership enables them to have easier innovation and actually spend less resources on firmware. And that whole term is called cloud firmware. What does it look like technically under the hood? Okay, cloud firmware is basically core boot and Linux boot running on your system. I'm not sure how familiar you are with the concept, but core boot is an open source firmware project, and we take core boot and take something from Intel, a set of binaries called the Intel Firmware Support Package, which are used for some silicon initialization here. Once core boot is done with all the hardware initialization, we jump to the Linux kernel, which is actually baked into the firmware image, and there you have a set of tools from where you can actually boot into your target OS. The collaboration model here throughout the last 1.5 years changed a bit from the typical model that you see on the left-hand side. All right. Typical model that you see on the left-hand side, where hyperscalers were normally working together with system vendors and silicon vendors to get their platforms up and ready, changed more to an open model where hyperscalers partnered up with different companies and really pulled in experts on where they needed them to be, and really worked very closely together with the community on enabling these platforms. How did that look like in detail here for the Open System Firmware Group and for that initiative, Cloud Firmware? Obviously, Intel partnered up with a couple of hyperscalers, namely Google, Meta, ByteDance, and also pulled in a couple of OEMs, Wiwin, Quanta, Inspo, Lenovo, Supermicro, and also pulled in a couple of independent BIOS vendors who are very specialized with open source firmware development. So that's us, 9 Elements, and also Syspro. And all of that whole effort was more or less steered by the Open Compute, Open System Firmware project, really steering and organizing the whole effort and bringing everyone together here. If you want to know more about the cloud firmware, like more from a technical side, basically, we published a white paper on coreboot.org where you can check out all the details, like how do I get started, how do I build the whole thing, how do I customize it, what about security and all these kind of things. We worked together on put like a pretty neat document together where you can check out all the details and can basically read everything up there. Okay, so you should have an overview on what cloud firmware now is and what the term means. And now we move to the actual execution and implementation at ByteDance. So ByteDance switched or started their move from the traditional solution that they had, that was a closed source UEFI based solution. They started that switch sometime around like 2020 and deployed the first version of cloud firmware in 2021, where they switched from a closed source stack to an open source stack, mainly using an open source variant or an open source implementation, EDK2. Used Linux boot on top of EDK2 and pulled in the Intel firmware support package to really to do all the silicon initialization here. That was actually deployed in production 2021 and was working quite well. However, they noticed, or they came to the conclusion that UFI is not what they need as the underlying platform there. So they replaced the open source UFI with core boot. So switch to the stack, basically what I talked about on my third slide here, have core boot together with the FSP and doing all the hardware initialization, and then going to a Linux boot kernel, or to Linux boot, which is basically a Linux boot kernel in RAMFS, and booting the whole system. That is called Cloud Firmware version 2. And is actually rolling out right now in the infrastructure. And the future plan for Cloud Firmware version 3 is to have that running not only with Intel platforms, but rather switching also to other silicon vendors and enabling the same stack, so core boot plus Linux boot, and just having other silicon vendors here as well. The working model basically is, as I just said, how they did the collaboration. So for the core boot part, they pulled in a couple of OEMs and ODMs to really work with them on the core boot low-level, hardware initialization part. They talked or worked with Intel on the whole silicon initialization and silicon code part, and they ByteDance took care of their own Linux boot part, and everything was done in very close relation or very close communication with the community itself. Right. The important thing is here that all of these different partners here were sharing the same code base throughout the whole project. This way, they were able to move very, very fast forward, basically. The schedule on how that was actually pulled off over the last 1.5 years is exactly. Hi there. Hi. It's exactly as I said. The whole thing started, or the planning started at the end of 2021, and then they did the heavy lifting of really developing core boot and Linux boot to get it to a production-worthy state. Mid-2022, they switched from when the heavy lifting was basically done. They switched into a validation phase where they really did a very extensive validation on the whole firmware stack, if it really is on par with their traditional solution that they had. As you can see, that it did like two rounds where they have a couple of adjustments throughout these rounds, and now they're in the phased rollout where they're really deploying Cloud Firmware 2.0 in their infrastructure. As I said, throughout this 6 months system validation phase, they run a couple of tests, like a couple of hundreds of tests, to really be extra sure that from a functionality, stability, and performance point of view, the core boot plus Linux boot solution is really on par with the traditional UFI solution that they had before, and came to the conclusion, and that's a quote, the overall status is pretty good. So I think that's good enough then. Right. So you see, they ran over 300 tests actually to validate the platform. The nice thing actually that they noticed is that there's no performance impact at all switching from the traditional stack actually to the core boot stack. So they had over 150 different performance measurements that they took, and how you read that chart is that on the x-axis there's there are the tests actually that they ran, and if the y-axis is 100%, it's really on par with UFI solution, right? So they really took core boot and UFI next to each other and did the same tests on the same platforms, but just with a different firmware stack. And if the percentage is under 100, UFI solution performed a bit better, and if it's over 100, the core boot solution performed a little bit better, and the overall average is actually really under 1%, so you could say that there's no performance impact at all. However, so functionality is good, right? Stability is good. Performance is great. So why switching, right? And what they notice is actually that they have faster time to market cycles here. So the legacy model worked like this: that Intel was releasing their own silicon code internally, did their own validation that needed to be integrated at the IBV, that then need to be integrated at the ODM, and then it was shipped to ByteDance, and ByteDance could do a full 4 weeks validation on the firmware image. And now with the open model and the direct collaboration with Intel, they can start basically when Intel has a candidate that they want to release, they can integrate it in 2 workdays and then start the full 4 weeks validation basically in parallel with Intel and cut down their time to market, like from candidate to actually deploying it on their platforms by more than half actually. So as you can see, the cycle before was around 9 weeks, and now we're at 4-week cycle to really get from the candidate into deploying it in the data center. All right. If you want to know more about it, the Open System Firmware project has a wiki on the Open Compute side, so you can check out the links here. You can get involved there. We have bi-weekly calls. We have an Europe-US friendly call, and we have an Asian friendly call. So no matter where you are located in the world, you can actually join these calls. And yeah, just get involved, talk to the people there. And if you want to know more about it, you can also catch me. Thank you. Oh, any questions up front? Great.
I have a question.
Yeah.
In the OSF firmware 3.0 that you showed on the first slide, I guess.
That one?
Yeah.
Yep.
How far are you with enabling a single binary image that could work on multiple silicon platforms? And do you see any challenges like supporting not only different x86 platforms but also ARM platforms with a single integration?
Yeah. So the question is, how far away are we from supporting different architectures basically with the same binary? And I think that is not the goal in that sense. So it's not the goal that you have one single binary to rule them all, let's say, but rather have the same code base, core boot and Linux boot, and just plug in different silicon init code into the core boot system, basically. Then you will produce different binaries, but like the code that brings up your hardware, not only the silicon, but the rest of the system, that stays consistent throughout all the silicon platforms that you have.
So the common point of intersection is the core boot right? The top end of the core boot.
Yeah, exactly. Right. Yeah, we just replace the silicon code that does the silicon initialization, right? Like bringing the RAM up and these kind of things.
You made a statement earlier that UEFI was not sufficient. Is that because of the timelines or the feature set, or too bloated, no controlled source code, all of the above?
Yeah.
Something else?
ByteDance came to the conclusion that UFI is not sufficient for their use case because the open source, so what they found out that the open source community around EDK2 was not vibrant enough for them, right? So they couldn't really get their patches in. There was like not enough interaction with the community. And they boiled it down also that they don't need the interfaces that UEFI provides actually, right? They don't need runtime services because they have very special use case on what they are booting. And that kind of removed UEFI out of the equation there. And then, I mean, what they're doing is, or what they did, is booting UEFI, then going to the kernel and KXing into another kernel, right? So you don't need the UEFI interfaces there. So they got rid of it. All right.
I got one additional one.
Yep. You got 5 more minutes, so it's great.
So core boot's been around a long time. I'm going to ask this as a 2-part core boot versus slim boot or other industry standard bootloaders? And then secondly, what has changed with the core boot implementation? Is it just a hardening exercise, or is it, additional features, et cetera, that is added to that?
So first question was why core boot and not other projects?
Yeah,
Was that right?
Yeah, other
Okay.
like slim boot, there's a lot of momentum there, things of that nature.
Yes. So Slim Bootloader is an Intel-driven project, right? So it has been started by Intel. Coreboot is a community-driven project where it's not owned by a single company, basically. And the Coreboot community is very, very big. It has been around, like as you said, over 20 years. And the whole build system of Coreboot and the code system that we have, we are sharing the code across all the platforms, basically. And we are really, our pragma here is that we only do what's needed to bring the platform up and running, and then we get out of the way. And I think that concept kind of fitted into the use case that ByteDance had. Why they made the decision to go for Coreboot and Slim Bootloader, I cannot say exactly, but from what I know, Slim Bootloader doesn't support server platforms. So it's more like a client platform thing, and Coreboot does support server platforms and client platforms. So it's well tested throughout all the different architectures. What was the second question again? What came into Coreboot, right?
What changed?
Yeah.
With this effort?
The support for server platforms in Coreboot wasn't as mature as it is now, basically, before we started the effort. So we did like 2 proof of concept with the Skylake Scalable and the Cooper Lake Scalable platform. So we brought in the first set of support, but the Sapphire Rapids, which is that effort is basically based on now, really brought in more functionality in terms of multi-socket support, for example. Like all the ACPI stuff around it and so forth and so and that basically came through that effort really into the project and is now upstream and open source available.
That's great, thank you.
Thanks. Anyone else? All right. Thanks. Then I leave it up to Raj.